friends, in this video I am discussing a theorem of differentiability. This is the fifth video in the differential calculus. This is the very important theorem in the differentiability. If f is differentiable at a point, then it is continuous at that point. You have to prove this theorem. Proof for this theorem is by data f of x is differentiable. Given that f of x is differentiable at x equal to a, therefore from the definition of differentiability, limit x tends to a f of x minus f of a by x minus a equal to f dash of a exists. Now limit x tends to a f of x minus f of a equal to limit x tends to a f of x minus f of a by x minus a and x minus a. We cancelling this x minus a and x minus a, we again get this only. Limit x tends to a f of x minus f of a. Here x not equal to a. Limit x tends to a f of x minus, we separately take the limit. Now we know that property of limits, limit x tends to a into b is equal to limit x tends to a into a and limit x tends to a into b. This is the one of the property of the limits. That's why I am taken like this. Limit x tends to a f of x minus f of a by x minus a and limit x tends to a x minus a. We know that this is f dash of a into, we are applying limit, we get a minus a as 0, then entire term becomes 0. Then limit x tends to a f of x minus f of a is equal to 0, and we take the limits, limit x tends to f of x minus limit x tends to a f of a is equal to 0 by the limit property. Limit, you take the limit to this and this, we get limit x tends to a f of x minus limit x tends to a f of a is equal to 0, and limit x tends to a f of x is equal to, we take the this function into right hand side, we get f of a, because this is the constant function. This is constant function. We are applying limit to any constant function, we get again constant only. That's why f of a, limit x tends to f of a is f of a only. Therefore f of x is continuous at x equal to a. Hence derivability at a point implies continuity at that point. Means differentiability at a point is implies that continuity at that point. You have to note that very important note. Converse of the above theorem is not always true. Not always true. Differentiability, this means every differentiable function is continuous, but converse is not true. Thanks for watching.